Hello everyone. Here is just a video to show how to work out the dimension of any physical quantity in a very simple way. So basically we make use of the fundamental quantity, the dimension of fundamental quantity to bring out the dimension of the derived quantity. So basically we have 7 fundamental quantities, which are, so the topic is dimension. So the fundamental quantities are: number 1, we have the mass, then we have length, then we have time, we have temperature, we have current, electric current, then we have amount of substance, then we have a luminous intensity, Good. So among these, the most useful one or frequently used are the mass, length, time, MLT. So now the dimension of mass is capital letter L, preferably to be in a square bracket, especially when we are working it out in theory. But it's objective. Normally they don't put it in a square bracket. And the dimension for length is capital letter L, and that of time is capital letter T. Now, before I proceed, this dimension of length, which is capital L, applies to any quantities that are measured in unit of length, which is meter. So we can as well say that breadth, height, distance, displacement, all has a dimension of capital letter L. Please take note. So anytime you see breadth, height, distance, or displacement, the dimension is what? Capital letter L. And time, the SI unit of time is seconds. So anytime you see anything in seconds, you should know that the dimension is what? It's in capital letter L. Capital letter T, sorry. So why out of what? Mass is a capital letter M. Now let's take example. Let's assume you're asked to find the dimension of velocity. Velocity is equal to what? Displacement from the formula. Displacement all over time. Sorry for the handwriting. Displacement over time. And as I've just explained, it shows that the dimension of what displacement is what? L. And the dimension of what time is what? T. This can be written as L multiplied by 1 all over T. I did not change anything. So 1 over T is the same thing as what? T raised to power minus 1. Negative law of indices of reciprocal. So I have L multiplied by t minus 1. So that will give me LT minus 1 as the dimension of velocity. Now, let's say dimension for what? Acceleration. Now, mind you, dimension of velocity and that of speed, they are the same. It's only when you take it to the issue of either scalar or vector that you can find differences between velocity and what? Speed. They have the same unit, and as well they have the same what? Dimension. So acceleration is equal to velocity all over what? All over time. Here is where the stress is, and that is where I'm going to give you the hint on how to find your dimension without much stress. In this case, you know, among these two parameters I'm going to use to find dimension of what acceleration is only time that has a dimension, which is capital letter T. Velocity has no exact dimension unless I have to go and find it, which I've already found here. So in a situation where I have not gotten this and I don't know it often, I have to go and do this above all this. I have to do it before coming to what? Acceleration. So I have done it. I have just put what? L T minus 1 here all over what? T. That will be equal to L T minus 2 by the time I brought it up here. So the dimension of what acceleration is LT minus 2. Now here I'm going to show you the trick now, the shortcut to doing it without those long steps of finding one before you can get another one. So the hint here is your ability. The hint is going to be very useful if you have the ability to know your formulas. Now, for instance, those things that I've just found, the acceleration, dimension of acceleration, I can just got it from what? From the unit. If I know that the unit of acceleration is what? Is unit of acceleration is nothing but what? Meter. It's nothing but meter per second squared. So meter translate into length because L as dimension because it's a unit of length. Second translate into T because it's a unit of what? Time, 10 minus 2. You see, as simple as this. If I want to find the dimension of force is equal to mass times acceleration. Now, it's only mass that has dimension, which is what? Capital letter M. But acceleration has no dimension. So quickly, assuming I have not gotten this one, quickly I'll just go to my book or my rough place space. Acceleration is measured in meter per second squared. So meter length, second time minus 2. So I'll just come back here. I have L T minus 2. So dimension for force is L T minus 2. I hope this is clear. Now again, let's get dimension for momentum. Momentum is nothing but what? Mass multiplied by what? Velocity. So mass has a dimension, which is capital letter M, but velocity, I don't need the dimension. I'll quickly come to somewhere. Here, I'll write the unit of velocity, meter per second. Meter translate into L as the dimension of length or displacement as the case may be, and second translate into capital letter T as a dimension of what? Time minus 1. So I'll come back to this place. I'll write it as LT minus 1. So the dimension for momentum is MLT minus 1. Let's take dimension for what? Pressure. Pressure is what? Force all over what? Area. Now, these two parameters has no direct what? Dimension. So sharply, all I'll do is that I know force is what? Mass times acceleration, and what? Area is what? Length times breadth. So length has a dimension of L, breadth has a dimension of what? L. So in that case, for this one, only the mass has a dimension. I'll write it capital letter M, but acceleration doesn't have exact dimension. From the form unit, I'll say, okay, acceleration A is meter per second square. So meter L, second T, then minus 2. So I'll come here, I have L T minus 2 all over L squared. Okay, L times what? L. So L, we cancel one L from here. So I'll be left with what? I'll be left with M T minus 2 multiplied by 1 over L, which I can write as, because 1 over L will be what? L minus 1. So it now becomes M L minus 1 T minus 2. I hope you get what we are doing. So these are the short way we can write our dimension without necessarily looking for what to do, finding one formula before you can get another one, all those long process. I hope it is clear. So the last but not the least, let us do for density. Density is equal to mass all over volume. Mass over volume. So here mass has a dimension, capital letter M, but volume has no exact dimension, but I know that volume is length times breadth times what? Height. So length is dimension is L, breadth dimension is L, height dimension is L. So we show that the dimension of what? Of volume is what? L raised to power 3. So in that case, density has a dimension of M L minus 3. Thank you for listening. I hope you find this helpful.